Okay, Assalamualaikum and good morning. Okay, so boleh dengar ke suara saya?
Dengar doktor.
Oh, okay, thank you. Okay, so we start with doa first. Okay, Bismillahirrahmanirrahim. Allah maftah alaina hikmataka wa anshur alaina min khazaini rahmatika ya arhamar rahimin. Ya Allah, bukakanlah ke atas kami hikmahmu dan limpahkanlah ke atas kami khazanahmu. Wahai Allah yang maha pemurah lagi maha penyayang. Amin ya rabbal alamin. Okay, so last week we do on structures, which is structures lah. Okay, so we have this frame. Okay, we have to do FBD for each member. So here we have two members, so we have two free body diagram. Okay, then we do as usual. Okay, we use equation of equilibrium. Okay, which is summation of fx equal to 0, fy equal to 0, and summation of moment equal to 0. Okay, so we have done for the first member is C, is it? Okay, so find AX, AY from free body diagram AC. Okay, and then find BX and BY from FBD BC. BC is, okay, this one. Okay. Okay, so dah jumpa dah? Dah find dah the answer? Okay, who wants to volunteer? 1 marks for presentation.
Kalau AX saya dapat 117.22 Newton.
Sekejap AS berapa? 100?
17.2 kan.
117, okay, 0.2 or 0.0 is acceptable. Okay, and then for AY?
39.756.
Sekejap, tadi siapa?
Fatimah.
Fatimah, okay. Fatimah Fatimah dah 3 marks lah. Okay, Fatimah ni. Okay, AY siapa?
Kita di Nurusna.
Okay, berapa AY?
39.756.
Okay, betul. Siti, Putri Nur Husna, is it? Putri Nur Husna ke?
Ya.
Okay. And then BX?
BX 97.56.
Okay, siapa tu?
Afika, Nur Afika.
Afika. Sekejap Afika ingat tak nombor berapa?
Tak ingat tapi depan-depan.
Okey. Afika binti Sulai Udin
Betul.
Okey. Okay, and finally BY.
Saya dapat 97.4 Newton.
Correct. Agi
Ya, doktor.
Okay. 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 So, any answer before we proceed on machines? Simple machine. Okay, since tak ada, then we proceed on machines. Okay. Simple machine. Okay, so machine is a structure which transforms input actions, force or couples to output actions. Okay. So this is the example. Okay. On machine. The pruner, okay, multiplies blade cutting power with the compound leverage mechanism. Okay. If a 20 Newton force is applied to the handles, okay, so here we see 20 Newton, okay, applied to each handle, okay, determine the cutting force generated at A, at the end of this cutter. Okay. Assume that the contact surface at A is smooth. Okay, so here there's no friction. Okay, now we have to do the free body diagram. Okay. Okay, so in this case, we have to draw two free body diagrams. Okay, first we will take this one. Okay, and then we will take on the blade. Okay, and then we take on the free. We have to draw the free body diagram of the blade. Okay. Sorry, bukan yang ni. Okay, wait ah. The first one is this one. Okay. And then we have the blade. First, the handle. Okay, one of the handle. Okay, either up or above, and then the blade. Okay. So now you have to draw the this one. Okay. Oh, tak boleh. Okay, now we have to draw this free body diagram for the handle. Okay. So we have 20 Newton, okay, already there. And then we have, okay, tengok for each connection tu tahu lah. Okay, so here at D ni we have connection previously with the blade, okay, like this one, okay. So this one we can see, okay, D and then this one E, right, okay. Okay, then, okay. Okay, so here we have DE. Okay, so here we put S DE. Okay, let's say we do it like this. So here we have DE. Okay, and then we have at C ni we have connection with the other blades, right? So we have C, and then we can say it has CX and CY. Okay, so here CX and CY. So here we have CX, okay, and then here we have CY. Okay, so we have only 1, 2, 3, and 4. Okay, so then we have to break up. Okay, so DE ni as usual you have to break into component X and Y. Okay, so since we have 3 unknowns, okay, so this one also we apply the equation of equilibrium. Okay, apply equation of equilibrium. Okay, which is we have summation of fx equal to 0, summation of fy equal to 0, and then summation of moment at certain point equal to 0. Okay, in this case, this one we have to do first. We have 3 unknowns here. Kita nak ambil mana? So, we have to take summation of moment equal to 0. Okay, the thing is, where we want to take it? At which point we want to take summation of moment equal to 0? Is it at C, D, or G? C. Why? We have 2 unknown. 2 unknown force. Okay. So the answer is summation. Find summation of moment at C equal to 0. So what is the equation? Okay. Okay. And then, okay, so this is your task, okay, for apa? For tomorrow, okay. And then, okay, for blades, and then for blades, okay, supposed to be from the equation you can get what is the force at DE. What is the force at DE? Okay. And then we do for the blade, the free body diagram of the blades. Okay. Okay, for the blades, okay. So we have okay, so here we have an object. Okay, so this is what is this? Apa tu normal force. Okay, which is this is surface. Okay, let's say here A, right? So this is A. This is A. So we can say this one is, we can say either AY lah. AY is simpler. Okay, so this is AY. Okay, AS we don't have AS because dia kata it is smooth surface. Kalau dia kata rough surface, then we will have frictional force. Okay, but since it doesn't have friction, it is smooth surface, so we neglect the friction force. Okay, then let's see. Okay, so we have connection at B, right? So since it is in two dimension S and Y, so suppose every connection we have X and Y, okay, force. So here we have, let's see, Px. Let's see, we do it. Tak kisah this one. Px, and then let's say we have Py. Okay, and then what else? So we have connection at E as well. Okay, previously kan kita buat this one, we have DE. Okay, so this one it will be opposite. Okay, so here it is downward to the left. Now DE on the blade will be opposite, which is outward and to the right. So this is FDE. Okay. Okay, so here we also name it FDE. Okay. DE. So here we just put E. Okay. So here we have FDE. Okay. Since let's say you have found FDE, so you will know FDE here. Okay. From FBD handle. Okay. Okay, so now still we have to apply equation of equilibrium. Okay. Which is summation of fx equal to 0, summation of fy equal to 0, and summation of moment at certain point equal to 0. Okay, so still in this case we have also three unknowns. Okay, since we already know FDE from the FBD of the handle. Okay, so here we still apply summation of moment. Okay, at B. Okay, now you have to find summation moment at B equal to 0. Okay, then you can find out what is the F. You can know what is the force of AY. Okay, back to the question, dia cakap apa tadi? If okay, mean the cutting force generated at A. Okay, so finally we can find the force at E, which is AY. Okay, so boleh faham ke? Okay, kalau boleh faham, we proceed Okay, kalau boleh faham, we proceed on the next topic. Okay, which is distributed forces. Okay. Okay, concentrated force does not exist. Okay, sebenarnya tak ada pun satu point je dia exist. Okay, sebab awak duduk pun, okay, let's say you duduk on your chair kan, dia bukan one point. So it is area of your bum tu. Okay, so concentrated force does not exist since every force applied mechanically is distributed over a finite contact area. Okay, kalau macam contoh awak berjalan pun, dia bukannya one point of force. Okay, dia maksudnya apa? Your surface area of your foot. Okay, when the applied region is not negligible, we must account for the actual manner the force is distributed. Okay, kita ada 3 categories. Okay, first we have line distribution. Okay, so this is okay. Okay, first we have line distribution. Okay, unit is Newton per meter. Okay, so A ni is the example of line distribution. Okay, and then we have area distribution, which is Newton over area. Area unit dia is meter squared. Okay, or kalau dia punya in physics we learn before this, unit dia is Pascal. Okay. Okay, then we have volume distribution. Okay, contoh for area distribution is B ni lah. Okay, so let's say this one dam. Okay, yang ni dam. This one is water. Water yang dam tu tahan. Okay, so water tu, this is dia punya force yang applied to the wall of the dam. Okay, makin dasar, makin dalam, so dia apply force yang lagi besar. Okay, tengok dia punya ni. Dia punya arrow ni, okay, let's say this one is shorter, so this apply a little force. Okay, the longer the direction, so it applies the force yang banyak lah. Okay. So, and then for the third category, we have volume distribution or body force. Unit is Newton over volume. Volume meter cube. So this is the example of volume distribution. Okay, so we have an object with a volume here. So this is, inilah dia punya distributed force. Okay, for a volume. Okay, now we have centers of mass. Okay, so sebenarnya tajuk kita basically kita nak tahu center of mass lah. Okay, and then okay, body force, okay, due to gravitational attraction of the earth, okay, or weight, is the most commonly accounted distributed force. Okay, this section treats the determination of the point in a body through which the resultant gravitational force acts. Okay. Okay, before this kita just ambil at the center kan, tapi tak semua weight tu distributed evenly. Contoh macam, okay, let's say macam this object kan, for A ni, it is not in round shape. Kalau round shape, kita boleh ambil at the middle. Okay, dia mesti, we have to calculate, okay, where is the center. Okay, center of gravity. Apply the principle of moments. Okay, the moment of the resultant force, okay, W or weight equal the sum of moments about the same as this of the force dW acting on all particles. Okay, so here we have, okay, let's say kita nak find dia punya X. Okay, let's say we have 3 dimensions X, Y and Z. Okay, let's say we want to find what is the center of X. Okay, so dia punya equation is like this. Okay, X, okay, and then dW, okay, this is integration, okay, and then over weight. Okay, and then same juga kalau Y, okay, we want to find center of Y. Okay, so Y, okay, and then integrate with dW over weight. Okay, same as Z, kita nak find center of Z, so integrate Z, okay, and then dW over weight. Okay, center of mass. Okay, so this one, let's say kita nak find center of mass. Mass ni is the same, okay? We don't multiply with gravity. If mass multiply with gravity, then we have weight. Okay, so this center of mass, same, center of X, integrate X dm over m, mass. Okay, same as Y, and for Y and Z center. Okay, okay, center of center of mass and centroids. Centers of mass and centroids. Okay, in vector form we have R. Okay, center of R, integrate R dm over mass. Okay, where R is in vector form lah, Si plus Yg plus Zk. Okay, and center R will be, saya tak ingat lah nak pronounce this one. Okay, this one lah. Okay, the density of body, okay, which is rho, okay, is its mass per unit volume. Okay, so X, okay, at center is equal to X, okay, and then rho dV, and then divide with rho dV. This one is volume. Okay, when the density of rho of a body is uniform throughout, the expressions defined is purely geometrical property of the body, and the term centroid is used. Okay, centroid. So this one, okay, at centroid. Okay, so at centroid, okay, is this one is what? Integrate X rho dV. Okay, rho dV is equal to, okay, V. Okay, and then multiply, divide with integration rho dV. Okay. Okay, kalau uniform, then we can cancel out the rho. So it's just right. It's just that integrate X the V volume over volume. Okay, same for Y centroid and Z centroid. Okay. Okay, here we have, okay, centroid of lines. Okay, dia sama je tadi, cuma just this one different sikit. Centroid of lines, areas and volume. Sekarang kita ada 3 kategori tadi kan. So we can find centroid for X. Okay, integrate X dl over L lines. Okay, and then let's say we want to find centroid of X for areas. Okay, of areas. So x centroid is equal to integrate x, okay, with dA over A area. Okay, centroid of volumes, we want to find the centroid x. So the formula is integrate x dV volume divide with V volume. Okay, so this one apply for Y centroid and Z centroid also. In a homogeneous body, center of mass always lies on a plane of symmetry. Okay, so macam ni we have line of symmetry. Okay, kalau di homogeneous, okay, since the moments due to symmetrical located elements will always cancel. Okay, so kalau for homogeneous, they always lie in a plane of symmetry. Okay. Okay, now choice of element for integration. Okay, so yang ni saya tak fokus sebab previous class is more on maths, nak proving ni. Okay, so if you want to learn more, you can do on yourself and ask me individually. Okay. Okay, so you can see. Okay, so this one I have give some example. Okay, so you can do if you are interested to know how the proving is. Okay. Okay, so composite bodies. Okay. What is composite bodies? Okay. When a body can be divided into several parts of whose mass centers are easily determined. We use the principle of moments and treat each part as a finite element of the whole. Okay, kalau kat sini we have, let's say we want to determine the centroid. Okay. Okay, let's say we want to find the centroid. Okay, summation of M is mass. Okay, mass. M here is mass. Okay. So summation of mass, okay, multiply with centroid, okay, and then divide with summation of mass. Okay, so dekat sini, let's say, first example ni, we have composite bodies. Okay, let's say composite bodies ni, we can divide the bodies into several parts. Okay, so let's say in this case, we have mass 1, mass 2, and mass 3. Okay, here, for mass 1 ni, we can find out what is the X. Okay, what is the center of X? Okay, so here is center of X. Okay, and then multiply with mass 1. Okay, and then what is the center of X2? Center ni, dia is calculated from one point tau. Bukannya at, let's say, saya nak tunjuk kat sini. Oh, okay. So center ni actually is counted from, let's say, from one reference. Okay, so let's say this is reference, or we can say it as, or x is equal to 0. Okay, so here x1 ni, let's say, is calculated from here. So let's say this one is 10. Okay, then x2 ni is also calculated from this reference. Okay, so until here maybe 20 cm, let's say. And then for x3 ni also, okay, determine apa center dia. At x3 ni, let's say this one. So then calculate it from here. So okay, let's say this is center. So this is maybe 40 cm, let's say 40 cm. So that is how we calculated. Okay, then this one, so multiply with M1 X1, okay, and then so M2 X2, okay, and then M3 X3. Okay, so then from this formula, we just summation is tambah. Okay, so M1 X1 plus M2 X2 plus M3 X3. Okay, then divide with summation of mass. Okay, okay, so that's it. Okay, okay, so for this one, okay, so let's say we have this diagram. Okay, locate the centroid of the shaded area. Okay, so here notice that we have to find the area. Okay, shaded area. So we have this one. Okay, so this is a composite mass or not? Can we divide it into several parts? Boleh ke tak boleh ni kita divide it into several part of area, several areas? Boleh kan? Okay. So the trick here is, sekejap stop sharing sekejap. Okay. Saya pun tak ingat dah sekejap Mana tadi? Okay, mana tadi saya tengok dah. Okay. Okay, so yang ni sekejap. We look bawah sikit. Okay, so this one. Okay, so this is the actual the actual diagram. Okay, so we have 12 inches. Okay, use this one. Okay, 4 inches. Okay, this is the dimension. Okay. Okay, now we have to divide into several parts. Okay, so in this case, okay, kalau tengok dekat sini, we divide into, first we have area 1. Area 1 ni is the rectangular part. Okay, and then we have triangle. So this is the second section. Okay, second area. Okay, so third area is half of the circle ni, semicircle. Okay, and then the last area, the fourth one is this rectangular over this one. Okay, and then what we have to do is, I tak lagi saya explain, oh tak ada. Okay, so this one. Okay, so we have divide into apa tadi? Okay, first we divide into the rectangular. Okay, this one. Sini ke? 12, right? 2, 3, 3, 3, 3, 9, 2, 11. Okay, betul lah. Okay, so this is first rectangular. Okay, and then we have second tadi apa Second is, okay, second is the rectangular. Okay, rectangular, triangle. Okay, so we have triangle. So this is second area, and then we have this one. Okay, the semicircle, third area, and lastly we have this one, the small rectangular here, which is area 4. Okay, then what we have to do is find the center of X. Okay, okay, center of X will be, okay, in this case for area 1, what is the center of X? Okay, so make sure this is your reference point, your reference. Okay, so here always start from here. So this one X equal to 0. Okay, so here berapa tu? X1 equal to 6 inches. Okay, and then let's say for you want to find center of area 2. Okay, so yang ni for triangle ni macam mana nak tahu dia punya center tu? Macam step bagi dalam ni. Sekejap. Supposed to be we have formula. Okay, actually from the proving, tapi proving tu panjang lah pula. So sekejap. Ada ke saya bagi English? Okay, kalau kat sini kan, eccentroid for apa? Triangle is B over H minus Y. Sekejap, saya tak bagi lah dalam ni. Okay, you can find in the Google. Okay. Centroid formula. Kejap. Mana yang simple? See this one. Okay. Sekejap, saya nak cari yang dia ada complete the whole. Ada ke? Okay. So this one. Centroid of simple. Tak boleh buka. Ayo, sekejap. Lagi tak kat sini. This one maybe. Okay. Kecil juga besar. Okay, so dia macam ni lah Kalau tengok dekat sini. Okay, hopefully dia. This one. Panjang. Okay lah. Copy and paste. Shift 3. Okay, so from here you can see that, okay, kalau triangle, okay, so you can find this one, okay, the centroid, okay, using this formula. Okay, we have triangle, right? Okay, and then here we also have semicircle. So you can find what is the centroid of X untuk triangle, okay, and what is the centroid for semicircle. Okay, kalau dekat sini, if you look here, for centroid for triangle is B/3. B ni is base, okay. Base dia 1/3. Okay, if we see, so the base here we have, okay, so let's say, here tadi we have apa 12, 3, 9, 2, 11. So actually yang ni 1 lah. So added. So this is 1. So this is 6. Dia punya base for ni, for rectangle ni is 6. Okay. So add centroid for this one. Okay. So this one is, the base is 6 inches. Okay. So let's say we want to find the centroid. Okay. We have B/3, right? Okay. So B/3, which is 6/3 lah. Okay. 6/3 is, let's say, 2 inches. But remember, we have to take from the reference. Okay. So here we have 12 tadi kan. So here we have 12. So centroid will be 12 plus 2 is 14 inches. So boleh faham ke? Dengar ke saya cakap ni?
Dengar.
Okay, so faham ke?
Faham.
Okay, so any question?
Doktor, exam keluar sampai ni ke?
Tak, exam keluar sampai classes bahagian frames. Bahagian frame structures.
Oh, okey doktor.
Saya cakap apa Bukan dalam tu method of section ke? Sampai method of section je. Okay, so kalau tak ada, so you can try to find what is the X1. Okay, carilah every eccentroid for each part ni, each area. Okay, esok kita sambung dalam kelas. Okay, so tu saja. Okay, Assalamualaikum.
Thank you, doktor.
Thank you, doktor.
Thank you, doktor.
Thank you, doktor.